just like we have arithmetic operations on real numbers, like for example 3 plus 3, 3 minus 3, 3 times 3, or 3 divided by 3, we have those same operations with polynomials, or with, in this case, functions. And we actually also have a fifth operation called composition that we will talk about. Okay, so let's talk about the four basic ones, and here are the setup. If you have two functions and you want to add them, you just add the function rules together, and same thing for subtraction, multiplication, and division. Let's actually work an example though. Alright, so we have two functions, f and g, and we will add first. Okay, so if we want to add the two functions, it would be written like this. This is the way to say that we want to add the functions f and g, and then we write of x. So this is f plus g of x. Okay, make sure that you say of right here, not times, because it can kind of look like multiplication, but it's not multiplication at all. So this just means we're going to add these two functions, the function named f, the function named g, and our input is x, but it's not multiplication. So that just means we're going to have, here, let me not skip any steps here. This just means that we will take the two function rules, the rule for f of x and the rule for g of x. And again, this is just function notation. This means the function named f, whose input is x, and this means the function named g, whose input is x. But this does not mean f times x or g times x. Okay, so no multiplication. Okay, so we're going to add these two function rules. What is f of x? This function rule right here. So 3x plus 7. Okay, and then plus, and to that we will add this function rule right here. G of x equals this. So 2x squared minus 1. Okay, and we'll simplify so that we can have a polynomial in descending powers of x. So I'm going to add some like terms. We have 2x squared plus 3x, and then 7 minus 1 is 6. Alright, so this is the new function rule for the new function that we've created by adding two other functions. Okay, and when you add two functions, you always get a function. Okay, let's do the same thing with subtraction. So now we want to subtract the two functions. So guess what? We're going to subtract everywhere instead of adding. So we would subtract f minus g. That would mean over here we're going to have to subtract. So we input the function rules exactly the way we did before, but we will subtract. And so what does that mean for us? That means we need to distribute this negative. Okay, so don't forget to distribute the negative to both parts in the polynomial coming after it. So we have minus 2x squared plus 1. Okay, and again, we're going to add some like terms. So in descending powers of x, negative 2x squared plus 3x, and this time it's plus 8 because 7 plus 1 is 8. Okay, awesome. And so we have this new function rule. So when you subtract functions, you always get a function. Okay, let's do multiplication. For multiplication, we're going to multiply, of course, the two function rules, just like you would expect. So multiply, and when we write multiplication, really, we juxtapose the function. So you could say f times g, but really we just do it like this, fg. Okay, juxtaposition. And so what does this mean? This means we're going to multiply the two function rules. So f of x times g of x. So we have 3x plus 7 and 2x squared minus 1. And of course, you have to make sure to distribute everything out. Okay, so distribute and we'll distribute this way as well. In this case, it's foiling. So we will have the first one, 6x cubed, and then outsides we get negative 3x. Inside we have plus 14x squared, and last we have negative 7. And again, we want to try to add like terms. We don't have any like terms, but I'll go ahead and write it in descending power of x just to have everything in the right order. Okay, and so when we have f times g of x, this is our new function. Okay, this is the new function name, this is the input, and this is the function rule. Great. Let's go ahead and also look at division. So division is a different one because with multiplication and addition and subtraction, when you multiply two polynomials, you end up with a polynomial. But in the case of division, when you multiply two polynomials, you end up with a rational expression. Okay, not a polynomial, but you still end up with a function. So that's good. So f of x divided by g of x, you plug in the two function rules. So 3x plus 7 divided by 2x squared minus 1. And you would try to simplify this if you could. I don't think we can simplify it at all. So this is it. All right, great. Let us then, we talked about the four common operations: addition, subtraction, multiplication, and division. We are going to move on to an operation that is unique to functions. Well, maybe not unique, but at least it's new compared to things you've learned before. And that operation is called composition. Okay, function composition. So functions have the ability to plug in some kind of input. Usually we plug in an x, maybe something like negative 3 or whatever, but we can actually plug one function in to another function. So in place of x, we're going to plug in g of x. Okay? So instead of plugging in x, we're going to plug in g of x into f. What does that look like? F of, in place of g of x, we'll put in this. Okay, let me use some colors so we can have everything coded. In place of g of x, we're going to plug in this. Okay, so f of 2x squared minus 1. All right, let's go back to black. That means that everywhere you see an x in the function f of x, we're now replacing that with 2x minus 1. Okay, so what does that look like? 3 times, and instead of x, we're going to plug in 2x squared minus 1, and then we'll still have the plus 7. All right, good? So we will go ahead and try to simplify this. We can distribute this 3, so we get 6x squared minus 3 plus 7. And we can add some like terms, so 6x squared plus 4. All right, great. And then f of g of x, we have a fancy way of writing it, and that is with a little circle. Okay, so f of g of x will look like that, and then we'll have our input. And this represents a new function, okay? So when you compose two functions, you get a new function, f composed with g, and then x is still our input. This is still our function rule, 6x squared plus 4. All right, great. Let's try to compose these functions the other way. I'm going to go ahead and clear everything and rewrite 3x plus 7, 2x squared minus 1. Okay, f of x was 3x plus 7, and g of x was 2x squared minus 1. All right. Okay, so we want to compose them the other way. So this time we're going to do g composed with f instead of f composed with g of x. So remember, what does this mean? This means we're going to, in place of x, we're going to plug in f of x. Okay, so we're going to replace x with f of s. Let me try the highlighter here. So in place of x, everywhere we see an x, we're going to replace it with an f of x. So f of x, this is going to be our replacement, 3x plus 7. I'm going to plug it right into g. So let's try that. This equals g of, okay, and instead of x, we're going to put in 3x plus 7. All right. So what does it mean to plug in 3x plus 7 in place of x right here? We're going to plug it in 2 times 3x plus 7 squared minus 1. Okay, so we just put in the 3x plus 7 right here. Okay, great. So now we want to simplify this as much as possible. Notice that this is squared, so it needs to be FOILed. So we have 3x plus 7 times 3x plus 7. Okay, and then minus 1. I'm going to go ahead and FOIL that out. That would be 2 times, and this will be 9x squared. Okay, and then 21x and 21x, so 42x plus 49 minus 1. All right, and way down here at the bottom, going to distribute the 2. 18x squared plus 84x plus 98, but it's going to be 98 minus 1. Okay, so 98 minus 1 would be 97. All right, great.